Maths channel. I'm now answering question number 7 from the June 2014 International A-Level Edexcel Mechanics M1 paper. And here we have a question about this inclined planes and connected particles. So we're told that two particles P and Q of mass 2 kilograms and 3 kilograms respectively, so 2 and 3 kilograms, are connected by a light inextensible string. So the string is light. The string is light. What's going on here? 1 second. The string is light and is inextensible. So light meaning we ignore its mass, no weight to it, and we also consider that the tension throughout the string all the way will be the same. And it's inextensible meaning any particles attached to it will have the same magnitude of acceleration and velocity as long as the string is taut. This is initially P is held at rest on a fixed smooth plane. So there's no friction on the plane. Inclined at 30 degrees to the horizontal. The string passes over a small, smooth, fixed pulley. Okay, so you have a smooth plane, so no friction, and the string passes over a small, smooth, fixed pulley, meaning smooth, meaning there's no friction in the pulley. Therefore, the tension in the string on either side of the pulley will be equal. Okay, fixed at the top of the plane. The particle Q hangs freely below the pulley and 0.6 meters above the ground, as shown in figure 3. The part of the string from P to the pulley is parallel to a line of greatest slope of the plane. Basically, all that means, as I've explained before in some other videos, if you looked at this from this kind of angle, if you're looking at this, you would see like a plane in front of you. I'm just going to draw it three-dimensionally. And basically, this is P, this is the pulley, and this is the string connecting them. This is the shortest distance from the point, from the particle P to the pulley. It's not like at an angle like this or that. It's just the shortest distance. That's what it means by when it says is parallel to the line of greatest slope of the plane. The system is released from rest with the string taut. There's tension in the string when it's released. For the motion before Q hits the ground, show the acceleration of Q is 2g over 5, and also find the tension in the string. Okay, so now what we got to do is consider the forces acting on P and Q. So as we mentioned before, P is 2 and Q is 3 kilograms. All right, so the weight of the particle P is 2 g newtons. Okay, let me just fix this in place so it don't keep moving. All right, and the weight of particle Q is 3g newtons. And that should act straight down, like that, straight down. Okay, so that's 2g newtons, and that's 3g newtons. Okay, and we have the tension in the string acting upwards for Q and also upwards for P. That's what's pulling P up, and that's what's slowing Q down as it falls. All right, so there's the tension in the string acting, and we have the reaction force when P is in contact with the surface acting perpendicular to the surface, which won't really affect our answer because we don't have friction today. So friction would be acting it would act down the slope, right? And Q is what's going to fall down, as I mentioned in the question. So the tension would be acting down, the friction would be acting down the slope, but there's no friction. So we don't have to consider that, of course. So now we have to work out the acceleration. So we know that this is going to accelerate down towards the ground. This is going to accelerate towards the pulley, up the plane. Okay. And we can form some equations here, but we have to resolve the force acting parallel and perpendicular to the plane. The weight, we have to resolve it parallel and perpendicular to the plane. So that's what we must do here, and that's what I'm going to do. So I'm going to consider the force. Let me change its color. Okay, so this is the component of the weight perpendicular and the component of the weight parallel to the plane. Okay, now we know that this angle must be the same as the angle to which the plane is inclined, and I will explain why for those of you who have an issue with that. So I know that this angle here is 30 degrees. Why is it 30 degrees? Well, let's kind of do a little proof for it. All right, I'm going to consider two triangles. I'm going to consider this little triangle here. We know that this is a right angle because this is vertical, this is horizontal. And in this big triangle here, I'm going to consider this angle here, which we know definitely is a right angle because this is perpendicular, this is parallel to the plane. All right, now I'm going to consider that this big triangle has this corner. And this little triangle has the same corner. So the big triangle has this corner, the little triangle has the same corner. So if we were to make a little sketch of these, let me just make it thin. If I was to take a sketch of these two triangles. So I'm just going to outline this triangle over here. Okay, I forgot that part, no problem. I'll paste it over here. Okay, so that's that triangle over there. Okay. Okay. So this angle is 90 degrees, and this angle is that angle in the corner. And if I was to do the same thing for this one, can I, let me see if this works. Nope. Oh, that's a disappearing pen. Okay. No. Okay, this is the one. So let me see if this will. Yes, okay. So I'll just make it a bit thinner. And I'll make it blue. Okay. So now I've got this triangle here, which represents the triangle over there, where we have a, so this angle has a right angle on this side. Okay, this triangle has a right angle over here. This triangle has a right angle over there. These corners are the same in both triangles. This corner is the same in this triangle and the big triangle. So by similarity, this angle and this angle must be the same. These two angles must be the same. These two add up. These three add up to 180. These three must add up to 180. These two are the same, so that must be the same as that. So in this case, this is going to be here, 30 degrees. Okay, so that's the reasoning behind why that angle is 30 degrees for those of you who are not sure of that. Okay, so I'll just get rid of this now and continue. Okay, so now we want to resolve the forces parallel and perpendicular to the plane. So if I want to consider the force here perpendicular to the plane, this angle has to be resolved in this direction. In this direction here. Okay. Now, for us to resolve in that direction, let me just draw this other line to make it clearer. Okay, for me to resolve in that direction perpendicular to the plane, I have to basically find the side which is adjacent, because you can think of this side here. Oops. You can think of this side here being like the opposite and this being the adjacent. So if I have to resolve it in this direction here, oops, what happened to my arrow? Made it too thin. Okay, if I have to resolve it in this direction here, I think I was messing around with the wrong one. Okay, excuse me guys. All right, so now, so if I was to resolve this force in this direction, I have to, it's like I'm finding the side which is adjacent. And you can now think of it another way, which I like to think of it, that we have to go through the angle that we're given. We have to go into the angle that we're given. In that case, we're going to use cosine, like we're finding the adjacent side. So the component of the force perpendicular to the plane will be 2g cosine of 30. And if I want to resolve the force going parallel to the plane, I have to go away. This is the force. I have to go away from the angle given to resolve it in the direction parallel to the plane. In other words, you can think of it, I have to find this component, which is the horizontal, which is parallel to the plane, which is like the opposite side. So you use sine. So this would be 2g times the sine of 30. Those are the components of this weight, parallel and perpendicular to forces to the plane. They are not new forces. They are just this force split up into its two components. And we always consider the direction of some motion of something and perpendicular to that motion. So now we're going to resolve the forces parallel and perpendicular to the parallel and perpendicular to the plane, and also for Q. For Q, we're just going to think of vertically. So Q is going to move down. So I'm going to take down as positive because Q is going to fall to the ground. So if you look at the resultant force is equal to the mass times the acceleration. So the resultant force here is going to be 3g minus t, and that's equal to the mass, which is 3 times acceleration, which we don't know. So the mass is not the same as the weight. So you don't say 3ga, you say 3a. Okay. The mass times acceleration. So this is an equation for Q. For P, we have an equation where it's parallel to the plane, going up the plane, in which case you're going to have t minus 2g sine 30 is equal to 2a, because this has got a mass of 2. And perpendicular to the plane, I don't think we'll need it, but I'll just write it down anyway. The reaction force is equal to 2g cosine 30. Okay, so we resolve the forces acting on these two particles as they're moving up and this one down towards the ground. So we want to show that acceleration is 2g over 5. So I can combine these two equations together. I can add the two equations together because then the t will be eliminated and we'll be able to find the acceleration. So if I add these two together, the t's are eliminated because you've got minus t plus t, which is 0. So you have 3g minus 2g sine 30 is equal to 5a. Now sine 30 is equal to a half. You know that sine 30 is equal to a half. So this is going to become g. So you have 3g minus g equals 5a. 2g is equal to 5a. So therefore the acceleration is equal to 2 over 5g meters per second squared. So we can see here, that's exactly right. 2 over 5g, 2g over 5, same thing. So there we have answered part 1. Okay, so this is for part 1. Now for part 2, we have to find the tension. So that's pretty simple. We can just use, for example, this formula over here. We can say that 3g minus t is equal to 3a, which means we can now replace the a with 2 over 5g. So 3g minus t is equal to 3 times 2 over 5g. So 3g is minus 6 over 5g is equal to t. So t is equal to, now this is going to be like 15 over 5 minus 6 over 5, which is 9 over 5g newtons. Okay, so that's 15 over 5 minus 6 over 5. That's 9 over 5 newtons. So there we have our tension, and there we have our acceleration. And there's part A completed. Okay, now we're going to go on to part B. Okay, now for part B. It says, on hitting the ground, Q is immediately brought to rest by the impact. Find the speed of P at the instant when Q hits the ground. Now, this is where there's a big misconception that many students have. What they think is that, we're going to consider the motion of Q. So first of all, what I would say is that the speed of Q as it hits the ground, okay, we can say, maybe a better word is the speed of Q with which it hits the ground, is going to be equal to the speed of P at the same time. Okay, so the time, because they're connected by this light inextensible string, the moment that Q hits the ground, the speed with which it hits the ground will be the same speed with which P will be as it moves up the plane. Okay, so if you want to find the speed of P at the instant when Q hits the ground, then we need to find the speed of Q when it hits the ground. It will be the same thing because they're connected by a light inextensible string. Okay, so now we got to find the speed with which Q hits the ground. So we have some information that will hopefully help us. So we know that if we're going to take, I'm going to take down as positive because it's moving down. Okay, it's moving down. So we're taking from this level to this level. That's what we're considering. Let's call it from A to B. Okay, we're going from A to B, what I've labeled there. Okay, so we're going down. Okay, so the displacement is going to be positive 0.6 meters because we're taking down as positive. It's going down from there to there. The initial speed was 0 because it was released from rest. The final speed, and this is where people make mistakes, is going to be what we're looking for. It's not going to be 0 because, yes, it comes to rest, but that's because the ground was there. The V would be the speed with which it hit the ground. Just like if you went to the top of a tall building and you jumped down, right? Without a parachute, for example, if you jump down, you're not going to hit the ground at 0 meters per second. If you did that, there'd be no problem. But no, you're going to hit the ground at some speed and the ground is going to make you stop and you're going to get hurt badly, right? So don't think that, you're going to hit the ground at 0 meters per second. Yes, after you've hit the ground, you'll be going at 0 meters per second and you'll be splattered all over the floor. However, you hit the ground at a certain velocity. That's the velocity we're trying to find. The speed with which the object hit the ground. You don't say, oh, it came to rest, so therefore that final speed is 0. No. The final speed was with the speed with which it hit the ground. It's very, very important because many students that have this misconception, they make this mistake because of a lack of some maybe common sense. So we need to keep our common sense when we do these type of questions, especially in mechanics. Now the acceleration is what we found. We're taking down as positive. It's going down at 2/5 g meters per second. And the time we don't know. We don't need to find right now. So we have S and U and V and A. Those are the quantities that we are going to use. So if you think about the equations of motion, V squared equals U squared plus 2AS seems like what we want to need. So V squared, we're trying to find V. So V squared equals U squared, which is 0 squared, plus 2 times 2/5 G times S, which is 0.6. Okay, so V squared is equal to, just stick that in a calculator. I'll keep it in terms of G for now. So you have 2 times 2/5 times 0.6, which gives us 12/25. So 12/25 G. Okay, so V is going to be root of 12/5, 12G/5. And that would even be 2√3, wouldn't it? 4 3 is 12. So V would be 2 times √3 G under the square root over 5 meters per second. All right, so that's going to be equal to, we can write down that as an exact value. So 12/25 times 9.8. Remember, we have to use 9.8 for M1 in Edexcel, and that gives us 4.704. Let's just make sure that we did that correct. So we have 12 times 9.8, okay, divided by 25. Take the square root of that. That gives us, oops, there's something wrong here. That should be 3/2. That should be 2√3. That's right, 2√3/5 times G inside there. What I did wrong? So we have 2 times √3 times 9.8. Okay, and all of that over, no. All of that over 5. Yeah, 2 points. So I did something wrong here. That's correct. For some reason, I put in my calculator wrong. It should be 2.1688. 2.1688. All right, so it's a good thing I checked there. So be careful when you do use your calculator. That can be written as 2.117. It can be written as 2.2. It can be even left in this form if you want to. All of those are acceptable forms for it to be written down. Okay, so if you write it as 2.2, 2.17, okay, you could write it as 2.2. Why? Because we used G. So for the Edexcel M1 papers, you can write things to 2SF or to 3SF or in terms of G for your answers if you use G in your calculation, right? So that's the speed of P at the instant when Q hits the ground, okay? And then it says, in its subsequent motion, P does not reach the pulley. Find the total distance moved up the plane by P before it comes to instantaneous rest. So I'm going to take a portion from this. Okay, I'm going to take a portion from this and let's see how that. So I'm going to take this bit here, take a small portion from here, and I'll paste it down here so I don't have to keep on. Okay, now let's have a look. So basically, at this point here, okay, P is moving with a speed of, and it was root 12 G over 5. I'll keep it in this form, meters per second. All right. So what's going to happen once Q hits the ground? Okay, P is going to be moving at that speed. It's not going to just stop straight away. All right, because Q stops, yes, but now the string is not taut anymore. It's just loose. Right. So once the string becomes loose, there's no more tension. Okay, there's no more tension. The tension has gone. Okay, because the string became loose. So the only force acting on P now is its weight, which is 2G newtons. And that's acting down the plane. That's acting down the plane. Right? So that's acting down this plane here. Okay, so if we resolve that force down the plane, then we're going to get basically 2G cosine, as we learned before, 2G sine, 30. This is 30 degrees, and this will be 2G sine 30. Okay, so it's moving up the plane. The acceleration is now gone. No more acceleration. This is not the acceleration anymore. This is no longer the acceleration. Why? Because there's a new, situation. So we cannot take this as acceleration. We have to find the new acceleration. When we find the new acceleration, we can work out how far it's gone up the plane before it comes to instantaneous rest. So obviously, we need to find the acceleration. So we need to find the resultant force. So if we consider up as positive because it's moving upwards, the only force is acting on it parallel to the plane is its weight, 2G sine 30, and that's negative. Why? Because that's acting down the plane and it's moving up. That's equal to its mass times acceleration. So the acceleration is going to be basically G sine 30, negative G sine 30. So the acceleration is going to be negative a half G meters per second squared. So now we can do that's using F equals the resultant force equals mass times acceleration. Now what we can do is we can use suvat to decide how far this moves up the plane after Q has hit the ground. Okay, so it's going to move a certain distance up the plane. All right. Now it's going to decelerate until it comes to rest. So at this point here, its speed is going to become 0 meters per second. So if we use our suvat equations, we want to find this distance that it moves. Call that S. Okay. All right. No, let's call this X. Let's call this X. Okay. Call this X. All right. So S equals X. U is the speed with which it was moving at the point that Q hit the ground, which is root 12 G over 5. V is going to be 0 because it's going to slow down, come to rest, and then start sliding down again. So we want to find that distance it moves by the time it reaches there. The acceleration now, as we know, is minus a half G meters per second squared, and we don't know the time. Okay, we have to find it. So we're going to use S, U, V, and A. So we can use again V squared equals U squared plus 2AS. So V is 0. U is this. So U squared is going to be 12G over 25. That's why I left it in this form. Makes it nice and simple. Plus 2 times a half G minus a half G, sorry, times S, which is X now. So those will cancel out. So you'll end up with, you can say minus 12G over 25 is equal to minus G times X. So the G's will cancel out. You're left with X equals 12 over 25 meters. So what's 12 over 25? 12 divided by 25 is 0.48 meters. So the total distance it moves, okay, so the total distance it moves up the plane is going to be it's going to move first 0.6 meters, okay. When Q hits the ground, it'll have moved the same distance that Q moved down, it would have moved up. So it's going to be 0.6 plus that distance X, which we just found. So the total distance moved, total distance is going to be 0.6 plus 0.48, which is going to be 1.08 meters. Okay, so that's the total distance it's moved up the plane. And then part D says, find the length of time between Q hitting the ground and P first coming to instantaneous rest. Okay, so we want to find the time it takes for this to happen. Okay, we want the time it takes for this to happen here. Okay, this is the time. This time here would be the same time, okay, between Q hitting the ground and P first coming to rest. That's what this is all set up for that. And then we added the 0.6 for it to find out the total distance. So this distance is traveled, it will be during this time. So here we can use V equals U plus AT. We can use V equals U plus AT. We know V is 0. We know U is root 12G over 5 plus, and we got A is negative. A is negative a half G. Okay, negative a half G, and T is what we have to find. So if we rearrange this, we're going to have basically a half times GT is equal to root 12G over 5. So T will be, it's going to be 2 times root 12G over 5G under the square root sign. So that should give us our time. So we have 2 times root 12 times 9.8 over 5 times 9.8. And that gives us 0.44262, 0.44262. Okay, just to make sure that's correct. Where's my calculator gone? 0.44262, yes. So we're going to round this to 3SF, 0.443 seconds. We could write it to 2SF, 0.44 seconds if we want to. Okay, but that is fine. 3SF is always the safest option. This will always be acceptable unless the question is stated otherwise. So there's the answer to part D. And that concludes this question from the June 2014 M1 paper. Okay, this is the way that I did the question. There's probably other ways you could deal with this situation here, but I think this is a nice simple way to do with it. Okay, be careful. Acceleration when the string has become taut, once Q has hit, or string has become slack, sorry, once Q has hit the ground, is no longer going to be the same as before. That's a big mistake people make. You have to find the new acceleration, which will be a deceleration, of course, because it's going to come to rest. If you carry on accelerating, you'll have a problem. It won't come to rest. It'll just carry on increasing in its speed. So there's the answer to this question. Other questions from this particular paper can be found in the playlist that will appear on the top right of the screen at the end of the video. Other questions from the topic of connected particles will be in the playlist that will appear in this section. Other questions from the topic of inclined planes you'll find in the playlist that will appear in this section over here. And if you would like to subscribe to my channel, you can click on the link on the top. Thank you for watching and see you soon.